Hello viewers, I'm Mr. Eric Akefa. In this week, it will be divided into parts. We having the first part and the second part because it's quite broad. So in this part, we'll be talking about pointers and arrays. That's very simple. Talking about pointers and arrays. So let's proceed to what we're about to do today. So let's start with pointers. Say, imagine you have a piece of paper with someone's home address written on it. The paper doesn't contain the actual house, but it tells you exactly where to find it. That's pointers. And let's move on to creating a pointer. So to create a pointer can be declared in the same way as any other variable, but with an asterisk symbol. So without the asterisk symbol, you can't declare a pointer. And with the pointers, we have structures for it. We have the data data type with the asterisk and the name they terminate it. So let me give you a practical example of it so that you get a clear view and a thought of it. So now let me launch my code blocks. Let me give it a title as Eric. I'm coming. Okay, so now let's proceed. Sorry for the distraction. Okay, so let's proceed. So to declare a pointer, that's let's declare a pointer that's int without this asterisk sign. Whatever you are doing is wrong. Int ptr determinate. Okay, this is how you can declare a pointer. So without the asterisk sign, you can't declare a pointer. So that means they said the data type. We learned about data type that we have the integer and stuff. So data type, asterisk, and the name. So this is how you declare a pointer. Now let's proceed. Let's move on to assigning addresses to pointers. So now that we have a pointer, we need to give it an address to point to. Use the address of operator, which is the @ symbol. So note this, without the address of operator, you can assign address to a pointer. So that's the symbol we have is the @ symbol. That's the @ symbol. So okay, let me comment this one, the declaration of pointers. So now let's move on to assigning addresses to pointers. It's quite simple. As we said, without the @ sign, we can assign addresses to a pointers. So let me give you a practical example for you to get a clear view and understanding about how it works. So I have int int val equals, we have 22 and I terminate. Don't forget to terminate it after you are done. I've declared my variable. Let me move to the second step. So with this, I've called the function. That's int val equals 22. I terminate. And one said that to declare pointers, you have to bring your asterisk sign. So let me bring that. So int asterisk ptr, that's ptr equals, we have here absa var I terminate. This is very simple. This is, we are assigning addresses to pointers. So first of all, I declared my pointer. Now I'm assigning the address I declared to my pointer. So let's run the code and see what we will see. So let me see out my code. So let's see out incoming. I see out val and end line I terminate. So in this case, we've assigned addresses to pointers. So now let's run our code and let's see the outcome of what we just did. Sorry, I muted myself. Sorry. So all what I just said is that we are moving to dual fencing, and with the dual fencing is the process of accessing the actual value that a pointer points to. So we think of the following, thinking of it like following the addresses of that piece of paper to the actual visit to the house. Yeah, let me put it that way. So with the dual fencing, it still uses the asterisk symbol, but it doesn't. It means go to the address to get the value stored there. So now let's get a practical example. So now let's proceed. We are about to dereference a pointer. So as I once said, it's the process of accessing the value present at the memory address pointed by the pointer. Is the same thing. So to declare dereferencing pointer, let me give you an example here. Let me give you an example. So I'll comment this. So we still say the int. So without the asterisk sign, it won't work. Int ptr. Let me bring my assignment sign. That's the equal to. Let me bring my absent sign. Okay, var, and I terminate. So all what you see here is I'm declaring dereferencing to a pointer. This how you this is the data structure that you have to know. So let me comment this and give you a practical example of it. So let's say int num equals let me see 42. Let me terminate. And I move to the second line. And don't forget to bring your asterisk. Your ptr, that's your pointer, equals, you bring your sign, that's num. That's, let's terminate it. Let's move to the second line, the third line. That's, we are about to see out what we just code. So see out, let me bring my see out sign, that's into double quotes, see out value pointed see out, bring the sign, hashtag ptr, let me end the line, and let's terminate. So all what you see here is dereferencing a pointer. So let me try and comment this one. Let me comment this one. Let me also comment this one. Now let's run our code. As you can see, the value gave us 42. This is it. This is the 42. This is it. Value pointed is 42. So this is how we dereference a pointer. So we are moving on to modifying a pointer address. So one of the powerful features of pointers is that you can change what they point to, as long as the new variable is of the same type. You can reassign the pointers. So that's modifying a pointer address. So let's look at how to declare it. So we have int, let me say int asterisk int asterisk ptr, assign the absent a, I terminate. So see ptr equals absent b, that's we terminate. So this is how you can declare or how to modify a pointer to address. So it's simple. Let me read something. It said one of the powerful features of pointers is that you can change what they point to. So that this is how we went about. We changed the A to the B because they are of the same kind. They are of the same kind. So it's very simple when modifying a pointer address. It's very simple. It's very simple. So now let's look at some practical example here. So let me have int kill. Int kill equals 10. Don't forget, in our previous lesson, we spoke about declaring multiple variables. So this is what I'm applying here. So I can't just be separating or be writing int x, int debe, and debe, int in so many forms. So with this, I'm trying to use what we learned the other time. So here I'm declaring multiple variables. So I'll be separating it with commas, as we said in our previous lesson. So int kill equals 10. I give my comma and I say b equals the assignment sign 2, and I terminate. I move to the second line. So we are modifying our address pointer, modifying a pointer to address, sorry. So int, we bring the asterisk sign, in asterisk sign, that's ptr equals, you bring the up sign as a, then you terminate. You move to the second line, the third line, that's let's see out ptr. Now let's end line and let's terminate. So let me comment this one. I have my comment sign, comment. Let me comment this one too. So now let's try and run our code and see for the outcome. Let me use B here, sorry. So let's run the code. So it seems there's a problem somewhere. There is a problem. I think I had a problem with modifying a pointer. So now let's rectify it. So let's say int a equals, let me give mine 5 and let me terminate it. No, since we are declaring multiple variables, so let me bring mine comma, let me say b equals, let me bring mine 10 and let me terminate it. Also int my asterisk, that's ptr equals a, let me terminate it. So let's see out ptr, let's see it. Let's run the code and see. So as you can all see, we had 5. We had 5. That means we've modified pointer address. Hey, Asari, maybe your phone, man. So we had 5. Is it? So now let's move on to data size of a pointer. So here's something interesting. All pointers are the same size, regardless of what type of data they point to. This is because they store memory addresses, and all addresses are the same size. The size depends on your computer's architecture. So on a 64-bit system, that's for 8 bytes, and on a 32-bit system, that's on a 4 byte. So, so we have special types of pointers. Now, let's discuss some special types of pointers you should be aware of. We have the wild pointers. They are pointers that haven't been initialized. They contain random memory addresses that may or may not be valid. This is dangerous because you don't know where they are ray pointing. Take note, you don't know where they are ray pointing. And let's move on to the null pointers. These are pointers that explicitly point to nothing. That's the null pointers. That they are empty, they doesn't point to anything. They are initialized to null to indicate they don't point to any valid memory location. That's for the null pointers. And also we have the void pointers. Pointers to values with no particular type. We have the dangling pointers. Pointers to earlier valid address even though references memory address is erased. So this is the end of pointers. Now let's move on, or let's proceed to references. And I think that one too is quite simple. So when we talk of references, you might wonder what's the difference between references and pointers. The key difference is how they are used. Pointers allows us to pass large amounts of data around efficiently. Instead of copying all the data, we just pass the address where the data is located. But with the references, they provide more direct way to work with the original data. Take note. They provide more direct way to work with the original data. They are like having direct connection to the original variable. False pointers are like having address where you can find the variable. So this is it. Pointers is like where you can find your variable. But with the references, they are direct to work with the original variable. With pointers, you have to find the variable. But this one, they are directed. That's how the references and the pointers work. So, so that's how it works. Mm, allow that. Now let's move on to arrays. Let's move on to arrays. So arrays contain multiple objects of identical type stored sequentially in memory. Individual objects in an array are called array elements, and array elements can be addressed using index or subscript. That's how array works. So defining array. That's we have the syntax, the example, and the data size. That's array. So array index. Array indexing is how we access individual elements. The index specifies the position of elements in the array, and it starts from 0, not 1. So the first index starts from 0. So we don't count arrays from 1, or we don't begin array from 1. It always starts with a 0. You have to start with 0. And so let's proceed. Let's move on to the initializing arrays. When we create an array, we often want to give it initial values. We can do this by providing a list of values in curly braces. So note this, arrays are presented in curly braces, not just a bracket, but in a curly braces. Now we will be doing practical examples of that. So Yes. Let's continue on. So let's declare an array. So as you all know, they said array is being written in curly braces, but we don't use the bracket. That's the parenthesis. So let's move on. So let me bring my string class. That's I'm using class. So we said curly braces. So let me write for. Let me terminate it. This is very important. Anytime you are done with, it's like putting a full stop to your sentence. You have to terminate it, else you get. So let's move on. This is how we declare arrays. So now let's move on to the initialization of arrays. So we are about to initialize an array. So let me use int num that's I'll bring my curly braces, that's 3. That means I'm declaring 3 variables. That's equals. Let me bring my assignment sign. I open my bracket. Sorry, open my brackets. Let me put in some numbers. Let me give some number 1, 2, 3. 3. I open my curly bracket. I terminate. So this is how we initialize arrays. This is how you do it. Int num, you bring the number of variables you are assigning it to. You open your brackets, you bring your curly brackets, you terminate it. So now let's move on to the next thing. That's it. Thank you. So now let's move on to changing an array element. Don't forget, the array is like our matrices. We have the 2 by 2, we have the 3 by 3. It's like matrices. That's how the array works. So we'll be doing some practical example here, changing an array element. So let me comment. Let me comment this. Let me comment this too. Let me comment this. So int my number. So int my number. That's my curly braces. Let me give it 3. My assignment sign. So let's have 10, comma. Let's have 20, comma, and let's have 30. So my number. We are here to know the index of the numbers that we just initialized. So let's see. It said my number. Don't worry, this I once said arrays start from 0. They don't start from 1. So my number. Let me bring my curly braces. 0. Equals okay 5. So this is I'm changing an array element. So first, our first index was like 0. So the 0 when we come here, 10 is our 10 is the 0 here, because in arrays we start from 0. So with this, I want to change the array element. That's why I brought the 0 equals the 5. Let me terminate this. Let me terminate this. So see out. See out. At the moment. To see out my number 0. So let's end line and let's terminate. So now we are changing an array element. So this is how we go about it. So now let's try to run the code and see what we will get. Correct. We've changed the index of the element. We've changed the number of the element. That's the index of 0 was 10. Now it has been changed to 5. So this is how you can change array elements. So now let's move on to multi-dimensional arrays. Thus, we have the 2 by 2 matrices, we have the 3 by 3 matrices, and so on. So now let's do some practical example here so that we get a clear view about what we are doing. So let me say string letters. Let me say we are using the 2 by 2. The 2 by 2. So assign equals, let me bring my curly. Let me, since it's a string, one says strings are placed in a double quote. So let me bring my double quote. So we have A, we have comma. Let me bring my double quote. We have B. Let me bring my comma. Let me terminate this one. Let me open my bracket. E, F. So see out letters. See out letters. Like 0. Let me end my line. Now let's try to run this code and see what we will get. No error, no error, no error. I'm connected.